we have a question before us. Okay, so we are going to read the question and I will lay a proper foundation to this particular question before we start to solve. Alright, so today's question is basically under heat transfer, heat measurement. Alright, so we're going to see the question. It says a liquid of mass 2 kg at 61 degrees Celsius is kept in a large vessel. If another 2 kg of the same liquid at 21 degrees Celsius is added to the liquid in the vessel, calculate the final temperature of the mixture. So before we solve, I would like us to have a proper foundation to how to attack such kind of question. Now, we shouldn't forget how it flows or how it is transferred. Okay, we're told that heat is always transferred from a body at a hotter temperature to a body at a colder temperature. It means a body at a hotter body to a body that is what? That is cold. That is the direction of heat flow. That's how heat flows, not from cold bodies to hot bodies. Alright? So it means that the hot body tends to lose heat to the cold body over time. And at the end of the day, because they are both in the same environment, they are both in the same space, they tend to have the same temperature. They attain thermal equilibrium. This is exactly what happens when you pour hot water into a bucket of cold water. After some time, after mixing them together, you observe that you cannot really tell the cold water from the hot water after some time. Because why? They will both be at the same temperature after some time, attaining what is called thermal equilibrium. That is exactly what happens here in this particular question, where a particular liquid of mass 2 kg was at this particular temperature, 61 degrees Celsius, was added to this same liquid of mass 2 kg but at a different temperature. So we see that this first one, it will lose heat to this other one at a lower temperature, 21 degrees Celsius. There is heat flow. So the first liquid loses heat and the second liquid receives the heat that was lost. Alright? So that's the foundation that we must have, that there is heat gained and there is what? Heat loss. Okay? So we are going to calculate the final temperature of the mixture at the end of the day. When both of them have been mixed, after some time, what temperature will the combined liquid now have? That's what they actually say. Okay, so we are going to be solving that. So there's one thing we must do to solve this particular question. You can see I've cleaned it, so I'll just consult my question from here. Alright, so the heat content of a body, like the amount of heat that a body or an object, a solid or a liquid, will have, depends on three major quantities. Depends on three major quantities of that body. And those quantities are the mass of the body, the specific heat capacity of the body, or let's say the nature of the body, specific heat capacity, which is a function of the nature of the body. It's usually represented with the letter C. Then the temperature change of that particular body. This is what gives us or tells us or gives us an idea on the heat content of the body. So when a body gains heat, it is based on these three things that it gains that heat: the mass of the body, its specific heat capacity, and the temperature change it receives will give us the heat content of the body. And that is given to us as H equals mc delta theta. mc delta what? Theta, where the mass here is the mass of the body. C here stands for the specific heat capacity of the body. And this is our temperature what? Rise. When the body moves from an initial temperature to a final temperature. So this is one formula, or this is the formula that we are going to be applying here, because this formula gives us, from this H now, it gives us the heat content a body can possess per time. Mass of the body, the specific heat capacity of the body, and the temperature change that body experiences during that time. It says a liquid of mass 2 kilograms. So it means there is a particular liquid. The mass of that liquid is given as 2 kilograms. And so that this liquid of this particular mass is at a temperature of 61 degrees Celsius. So I'm going to call this particular temperature, since it's the first temperature mentioned, I'm going to call it my theta 1. My theta 1, and I'll give it 61 degrees Celsius. This theta 1 belongs to the mass of this liquid, that is 2 kilograms. Alright? Then it goes on to say that it is kept in a large vessel, full stop. If another 2 kilograms of this same liquid, this same liquid, another 2 kilograms of it. So it means I'll change this one to ml1, then another one, I'll call it ml2. It is also 2 kilograms. It is not saying if it is at a temperature of 21 degrees Celsius, since it is the second mass I have, I'm going to give its temperature theta 2. That will give us 21 degrees Celsius. 31 degrees what? Celsius. Full stop. Calculate the final temperature of the mixture. Wow. We have to find a third temperature, which is the final temperature of the mixture. So calculate theta 3. Calculate theta 3. And as you can see from this formula I gave to us earlier, mass was given to us, a temperature was given to us, but C was not given to us. Why was C not given to us? Because C is not necessary to solve this particular question. Now you will ask me why? Because I'm dealing with liquid of the same type. Let's say water, or kerosene, as the case may be. It is of the same liquid, so they will have the same specific heat capacity. And at the end of the day, they will cancel out. So we proceed to solve this question right about now. Between liquid 1 and liquid 2, they have the same mass, but then their initial temperatures differ. So we see that liquid 1 is the one that is losing heat, while liquid 2 is the one that is gaining heat. Alright? Now from this formula, I'm going to spell this formula as my star. I'm going to call this one equation star. Now, heat gain is always equal to heat loss, because energy is always what? Conserved. When the body loses heat and the other body gains that heat, that is exactly what happens here. Heat gain equals heat loss. Heat gain by the second liquid is equal to the heat that was lost by the first liquid. And heat content I gave earlier as H equals mc delta theta. So we have that for heat gain to be mL2, because it is the second body, the second liquid that gains heat. So it will be mL2 times C times delta theta equals, for heat loss, it is the first body that lost heat. So it's going to be mL1 times C times delta theta. As you can see here, I wrote delta theta. Alright? So let's expand this delta theta now. So we have mL2 times C times delta theta represents a change. It's called temperature change, temperature difference, rise in temperature, difference between an initial temperature and a final temperature. In this case, for the body that gains heat, its initial temperature will be smaller than its final temperature. So for this one, the final temperature minus initial temperature. And very well, we know that the final temperature is what we are told to look for heat gain, because at the end of the day, this second liquid, we are saying a temperature that is greater than its initial temperature. So I'm going to have theta 3 minus its initial temperature, theta 2, equal to mL1 times C times, for this other body, this is the one, this first liquid is the one that is gaining, sorry, that is losing heat. So we are going to observe that the final temperature will be less than its initial. So in the final sequence, we're going to the next. We have theta 1 minus theta 3. So this is what we'll be following, and our target is to obtain theta 3, which is equal to the final term that we have to look for. Final termination. It's now time for us to impute our values. So let's start. ML2 is given to us by 2 times C times theta 3 is what we are looking for, the final temperature of the mixture, minus our theta 2 is 21. All of this will be equal to ML1, that's the same 2 kilogram, times C times theta 1. Theta 1 is 61 degrees Celsius, so that's 61, minus theta 3. Remember, our focus is to obtain the final temperature of the mixture, theta 3. So from here, C we cancel out C, 2 we cancel out 2. At the end of the day, I have that theta 3 minus 21 is equal to 61 minus theta 3. So collecting items from here, I'll have this come this way. If this comes this way, it becomes theta 3 plus theta 3 equals 61 plus 21. 2 theta 3 plus theta 3 will be 2 theta 3 equals 61 plus 21 give us 2, that's 82. That give us 82. To make theta 3 the subject, I will divide both sides by 2, and that will end up giving me that theta 3 is equal to 82 divided by 2, that is 4, and that is 41. So 41 degrees Celsius. This will be the final temperature of the combined liquid. After they are mixed together, this will give us the final temperature. So we see that the liquid 1 went from 61 degrees Celsius to 41 degrees Celsius. It gave out heat. But liquid 2 went from 21 to 41 too. So it gains heat. But this 41 degrees Celsius is their final temperature. That's the temperature of thermal equilibrium. Alright, so this is quickly the solution to this problem. I believe this is very clear enough, and do not forget, if there is something that is still not clear, you can reach out to me on the comments in the comment section, and I will likely give a follow-up video for that, or better still answer your question in the comment section. Do not forget, if this video has been helpful to you, please do well to drop a like, do well to drop a follow, alright, and hope to see you come here once again to watch our video.